Hi all, let's start a new topic, halogen compounds. Today I'm going to discuss about the classification and nomenclature of alkyl halides and preparation and reactions of Gem and Vic dihalides. This halogen compounds, this topic includes both alkyl halides and aryl halides. First, let's discuss about alkyl halides. They are compounds having general formula Rx, and this R could be alkyl or substituted alkyl or cycloalkyl groups. Let me give you some examples. First one, this is CH3Br. Okay, this is the first. This is an alkyl halide, and then substituted alkyl halide. That substitution could be any other alkyl or aryl group. For example, this one. This is benzyl bromide, and this is not an aryl halide. This is an alkyl halide because this bromine is attached to a CH2 group directly. Okay, so methyl bromide, benzyl bromide, and then cyclohexyl bromide. Right? This is cyclohexyl bromide. These three are the examples of alkyl halides. And this X could be any halogen like fluorine, chlorine, bromine, or iodine. Okay. Otherwise, we will be giving another definition like alkyl halides are those compounds in which the halogen atoms are attached to an sp3 carbon atom. Okay, the halogen atoms are attached to an sp3 carbon atom. And aryl halides are those halides in which the halogen is directly attached to an aromatic ring. Okay, so the carbon atom will be sp2 and this halogen is directly attached to an aromatic ring. For example, we know the example of this one. This is bromobenzene. This is an aryl halide. And this methyl bromide, benzyl bromide, and cyclohexyl bromide are the examples of alkyl halides. Classification and nomenclature. I'll be dealing with them simultaneously. Okay. The first classification is based on the number of halogen atoms present. Okay. Based on the number of halogen atoms present, they can be monohalogenated, dihalogenated, or polyhalogenated. This polyhalogenated include tri and tetrahalogenated compounds. Okay, first one is CH3Cl. The common name is methyl chloride. The common name is methyl chloride, and the IUPAC name, we know that there is only one carbon atom, so this is chloromethane. Okay, this is chloromethane. Second one here, this is ethyl bromide, and the IUPAC name is bromoethane. And the third one is cyclohexyl chloride, and the IUPAC name is chlorocyclohexane. Okay, this is a simple nomenclature. You have been studying this one even in your high school classes, I think. Okay, so this next one is dihalogenated compounds, and this is methylene chloride. Okay, methylene chloride, and common name is methylene chloride, and we will be calling it as MDC also. Okay, MDC also. It's a very good solvent in the organic synthesis. And the IUPAC name is there are two chlorine atoms and there is only one carbon atom. So this is dichloromethane. And this second one is ethylene bromide. You see, this is ethylene bromide. Okay, we know that this is ethylene. CH2 double bond CH2 is ethylene, and here this bromine is added to give CH2Br, CH2Br. So this is considered as the bromide of ethylene. Therefore, this is the common name is ethylene bromide, and IUPAC name. These are similar, so we can number it as from anywhere we can start the numbering. So this is 1,2-dibromoethane, 1,2-dibromoethane. And the next one is ethylidene chloride. Okay, ethylidene chloride. This common name is ethylidene chloride, and the IUPAC name is this one. That in the first carbon there are two chlorine atoms, so 1,1-dichloroethane, 1,1-dichloroethane. Okay, now let's come to the polyhalogenated compounds. Okay, we are well versed with the common names of these compounds such as chloroform and carbon tetrachloride. Okay, the IUPAC name of chloroform is trichloromethane. Okay, trichloromethane, and the IUPAC name of carbon tetrachloride is tetrachloromethane, And there is another example given here. It doesn't have a common name, so the IUPAC name is 112-trichloroethane. 112-trichloroethane. So this is the classification, the first classification based on the number of halogen atoms present. Okay, let's see the second type of classification based on the attachment of halogen atoms to a primary, secondary or tertiary carbon atoms. Okay, if the halogen is attached to a primary carbon, we'll call it as a primary halide. If the halogen is attached to a primary carbon atom, we'll call it as a primary halide. So here in this example, there are 4 carbon atoms. This is 1-bromobutane, right? This is 1-bromobutane, and the common name is N-butyl bromide or normal butyl bromide. And here this is isobutyl. This is 1-chloro-2-methyl-propane. That's a IUPAC name, and the common name is isobutyl chloride. When it comes to alkyl halides, both the common names and IUPAC names are important. So we will be dealing with their common names more often. So please be thorough with the common names also. Okay. And now let's see here the bromine is attached to the carbon numbered 1, right? And this carbon is directly attached to only one carbon atom, that is the second carbon atom. Therefore, the carbon number 1 becomes a primary carbon atom. Okay. The definition of a primary carbon atom is that the carbon atom which is directly attached to only one carbon atom is called a primary carbon, and the carbon atom which is attached to 2 other carbon atoms directly is called a secondary carbon atom, and a carbon atom which is directly attached to 3 other carbon atoms directly, they are called as tertiary carbon atom. So in the both examples given here, the carbon atoms are primary, which means that they are directly attached to only one carbon atom. Here in this example, you can see that there are 2 methyl groups. Okay, there are 2 methyl groups, and there is a CH2 group and there is a Cl group, and this is the carbon number 1. This is 2, 3 and 4. Let's number like that. And here you can see that this chlorine is attached to a carbon, a primary carbon. Okay, carbon number 1 is a primary carbon. Okay, എന്തുകൊണ്ടാണ് primary carbon എന്ന് പറയുന്നത്? This carbon is directly attached to only one carbon atom. Okay, carbon number 1 is directly attached to only carbon number 2. Okay, hope you got the idea. So these two compounds are the examples of a primary halide. Okay, now let's see the secondary halide. Here, the halogen is attached to a secondary carbon atom. Okay, the definition is simple. Here, a halogen is attached to a secondary carbon atom. Okay, in the first example, you can see that the Cl is attached to carbon number 2, and this carbon number 2 is directly attached to carbon number 1 and carbon number 3. So 2 other carbon atoms. Okay, here the halogen is attached to a secondary carbon atom. Okay, here the halogen is attached to a secondary carbon atom. In the second example also, bromine is attached to carbon number 2, which is a secondary carbon atom, because this carbon number 2 is attached to carbon number 1 and 3. Okay, 2 other carbon atoms, therefore it's a secondary carbon atom. Okay, and let's see the tertiary halide. Tertiary halide is the halide in which the halogen is attached to a tertiary carbon atom. Here carbon number 2 is a tertiary carbon atom. Okay, because it's attached to carbon number 1, 3 and 4. Let's number it as 4. So this is a tertiary carbon atom. Okay, and therefore this halide becomes a tertiary halide. And here the common name of this compound is important. This is tertiary butyl bromide. Okay, tertiary butyl bromide. And here in the second example also, the carbon number 2, the bromine is attached to carbon number 2, which is a tertiary carbon atom. Okay, carbon number 2 is a tertiary carbon atom. Therefore this halide is an example of a tertiary halide. Hope you got the idea. So we have dealt with the classification and nomenclature. Now let's move to the next topic. Vicinal and geminal dihalides. Dihalides are compounds in which there are 2 halogen atoms present in a single compound. Okay, they can be of two types, which are vis dihalide, which are vis dihalide and gem dihalide. Vis dihalide is otherwise known as alkyline halide. Okay, two halogen atoms on adjacent carbon atoms. The name came from a foreign word which means neighbors. Okay, which means neighbors. Okay, vis means neighbors because the halogen atoms are situated on adjacent carbon atoms, and this gem meaning comes from the word, the meaning is twins. Twins means on the same carbon atom there will be two halogen atoms present. Okay, alkyline and alkylidine. Alkyline means vis and alkylidine means gem. Now let's see the methods of preparation individually. First is the method of preparation of vis dihalide. That's pretty simple. You have learned it in the addition reactions also. So from alkenes, when alkenes are treated with halogens, you'll be getting vis dihalide. I've given an example of propene plus chlorine. What is the compound? This is 1,2-dichloropropane. 1,2-dichloropropane. Okay, 1,2-dichloropropane. So this is a simple reaction. You know the reaction, right? So this is the first method of preparation of a vis dihalide. Alkenes plus halogens. Directly you will get a vis dihalide. Second preparation is the treatment of PCl5 with ethylene glycol with glycols. Okay, this is a simple nucleophilic substitution reactions. Okay, this is a simple nucleophilic substitution reaction in which both the OH hydroxyl groups are replaced by the halogen atoms present. Okay, so you will be getting a vis dihalide. This is ethylene chloride, right? Common name is ethylene chloride. This is ethylene glycol, to be specific. This is ethylene glycol. Ethylene glycol plus PCl5 gives you ethylene chloride. And the byproduct is important here. This is POCl3, phosphorus oxychloride, and 2 molecules of HCl will be formed. Okay, these are the two methods of preparation for gem dihalide. Sorry, for vis dihalide. Okay, from alkene and from glycols. Now let's see the preparation of a gem dihalide. First one is by the addition of HX to alkynes. Sorry, by the addition of hydrogen halide to alkynes. Okay, here I have given an example. This is acetylene plus 2 molecules of HCl. What happens when acetylene is added to, when HCl is added to acetylene? You will be getting vinyl chloride first, because hydrogen will, here both the carbons are similar. So hydrogen will add to one carbon and fluorine will add to the other carbon atom. So you will be getting vinyl chloride. Okay, this is vinyl chloride, and again one molecule of HCl is added. Now here we have to follow the Markovnikov's rule. Markovnikov's rule says that hydrogen goes to that carbon which contains more number of hydrogens, and the halogen occupies the next position. So you will be getting CH3CHCl2. Okay, this is the method of preparation for a gem dihalide. And the second is from aldehydes or ketones. This is the general reaction given. RCHO will be converted to RCHX2. Okay, I have taken a specific example of acetaldehyde and PCl5. You can see here that what happens is that this oxygen, see, instead of this CH double bond O, that gets substituted with 2 chlorine atoms. Okay, they are exchanging, and this oxygen goes to this PCl5 and 2 chlorine atoms go to this aldehyde to give you this one. Just the swapping, okay, just the swapping of atoms takes place. So CH3CHO will give you CH3CHCl2. Instead of one oxygen, two halogens are added. Okay, and then the byproduct is POCl3. And if you take acetone, you will be getting CH3COCH3 is converted to CH3CCl2CH3. Okay, just swap the positions of oxygen and halogens. Okay, these are the methods of preparation of gem and vis dihalides. Now let's see the interesting reactions of them. First one, I'll be discussing together the reactions together. Reaction with alcoholic potash. First one is the reaction with alcoholic potash. Both gem and vis dihalide. Here I have taken the example of ethylene chloride and ethylene chloride. Okay, and both gem and vis dihalide will give you acetylene on reaction with alcoholic KOH. So both give the same product. Okay, here you can see that this is a simple elimination reaction which takes place twice. Okay, here in the first step, chlorine, let's number it 1, 2. Okay, the carbon, I have numbered the carbon atoms. Chlorine from first carbon and hydrogen from second carbon are eliminated. Okay, and in the next step, chlorine from second carbon and hydrogen from first carbon are eliminated, which means that 2 molecules of HCl are eliminated. Okay, 2 molecules of HCl are eliminated to give acetylene. Here also the same thing happens. Okay, here you can see that there are two halogen atoms, and here there are 3 hydrogens, so we will be taking only 2 hydrogens. Here again 2 molecules of HCl are eliminated, like in the first example. Okay, 2 molecules of HCl are eliminated to give the acetylene. Okay, so when treated with alcoholic potash, both gem and vis dihalide will give you the same product. Like the same, if you heat it up to 400 degrees Celsius, it's a pretty high, very high temperature. If you heat it up to 400 degrees Celsius, both gem and vis dihalide will give you vinyl chloride. Okay, this product is vinyl chloride. Okay, both of them will give you vinyl chloride. Here only 1 molecule of HCl is eliminated from both gem and vis dihalide. Here in the case of this vis dihalide, chlorine from carbon number 1 and hydrogen from carbon number 2. Okay, here also chlorine from carbon number 1 and hydrogen from carbon number 2 are eliminated to give the same product, which is vinyl chloride. So we cannot distinguish between gem and vis dihalide with these 2 reactions because both of them will give you the same product. Now we need some reactions with which we can distinguish between a gem dihalide and a vis dihalide. Okay, so let's see such reactions in the next slide. See, if you treat this one with aqueous KOH, we'll be getting different products. Okay, reaction with aqueous KOH, or which is a simple basic hydrolysis. Okay, I have taken a vis dihalide first. This is a vis dihalide, and I have treated with potassium hydroxide solution, aqueous potassium hydroxide solution. I'll be getting ethylene glycol because these two, this is a simple nucleophilic substitution reaction. It's a simple nucleophilic substitution reaction in which the halogens are substituted by the OH group of the reagent to give ethylene glycol. So a vis dihalide gives a glycol. Okay, a vis dihalide gives a glycol. Vis gives glycol. And let's see the product of a gem dihalide. Okay, this is a gem dihalide, ethylene chloride, and when it's substituted with KOH, first step is the same, that is 2 halogen atoms are substituted by 2 hydroxyl groups, and so we are getting a gem diol. Let's write it here, CH3, CH, OH and OH. If you heat it further, 1 molecule of water is eliminated like this. 1 molecule of water is eliminated like this to give CH3, CHO, acetaldehyde. Okay, so in both the cases, first step is the same. In the case of vinyl dihalide, the reaction stops at only 1 step because this chlorine atoms are substituted by hydroxyl groups to give a diol. But here, a vis diol. Okay, a vis diol. Here in the gem dihalide, in the case of gem dihalide, first step is the same, that halogen is substituted by OH groups, but there are 2 OH groups in the same carbon atom. on the same carbon atom. So that's an unstable condition. Therefore, it rearranges by the elimination of a water molecule to give a more stable aldehyde. Okay, here in this case we are getting acetaldehyde. So Vis gives glycol and Gem gives aldehyde. Okay, so this reaction can be used to distinguish between a Gem dihalide and a Vis dihalide. Let's discuss one more reaction with which we can distinguish between both of them. Here the reagent is aqueous KCN, potassium cyanide solution. Okay, potassium cyanide, aqueous KCN. In the first step, it's again a nucleophilic substitution reaction. Nucleophilic substitution reaction. Halogen is substituted by cyanide group. Okay, and CH2CN, CH2CN, we are getting a dicyanovicinal cyanide substitutions. And if you hydrolyze, when you should know that cyanide group on hydrolysis always gives a carboxylic acid group. Okay, CN group on hydrolysis will give you COOH all the time. Okay, that's a general universal reaction. CN on hydrolysis will give you COOH. Okay, so in the first example, we have taken ethylene chloride and that is converted into succinic acid. That is converted to succinic acid. On heating, one water molecule gets eliminated like this to give succinic anhydride. Water molecule gets eliminated to give succinic anhydride. So what we can understand is that a Vis dihalide with reaction with KCN will give you the end product as anhydride. And let's see what happens with the Gem dihalide. First step is the same. Two Cl atoms, two halogen atoms have been replaced with two cyanide groups. Okay, so on hydrolysis you are getting, this is methyl malonic acid. Methyl malonic acid. Okay, methyl malonic acid. And here you can see that two bulky COH groups are present on the same carbon atom. Okay, two bulky COH groups are present on the same carbon atom. That's rather unstable condition. So on heating, a CO2 molecule is easily eliminated. A CO2 molecule is easily eliminated to give CH3CH, and this hydrogen is remaining over there. So CH3, CH2 and COH, which means a propanoic acid. So what we can conclude is that when a Vis dihalide is treated with aqueous KCN, the end product is an anhydride, and when a Gem dihalide is treated with aqueous KCN, the end product is a carboxylic acid. So these two tests can be used to distinguish between a Gem dihalide and a Vis dihalide. Hope whatever I have discussed today are clear. The topics are clear for you people. Thanks for watching this video. Thank you.